All right, so an iceberg is floating in a straight line at a speed of 1 mile per hour. All right, meanwhile, a geologist is tracking it from her ship. The geologist's ship, which is following the iceberg path exactly. All right, so here's the iceberg. Here's, I don't really know where I'm going with this ship right here. There's the ship. Following the iceberg path. It is currently, okay, so this distance right here is 260 miles behind. And this iceberg is going 1 mile per hour. 1 mile per hour. And this thing, this ship right here is traveling at 15 miles per hour. 15 miles per hour. How long will it be before the ship reaches the iceberg? Okay, so
wait,
you got one going at one speed, which is way faster speed, and you got this other one going at this speed right here, right?
Uh-huh.
So, okay. Okay, I'm gonna just kind of like do it this way. So you have one guy right here. I'll put it at 0, and then you have one at here at 260, and this one right here is moving at 1 mile. And this one right here is moving at 15. Okay. And at some distance over here, they're going to meet up because this one's going faster. Right?
Mm-hmm.
Okay. All right, so we can do our box. So distance equals rate times time box.
Mm-hmm.
It's the ugliest box ever. Yeah. All right, so distance equals rate times time, and we have our iceberg, and we have our ship, and we know the ship's rate. The ship's rate.
Mm-hmm.
What's the ship's rate?
Was it 15 miles per hour?
Yeah, the ship's rate is 15. What's the boat's rate? I mean, the iceberg's rate?
1 mile per hour.
1. And then also, like, I'm not putting the units in there because everything is like, they're not being mean here. It's all miles, it's all hours, it's all miles, and it's nothing switched to seconds or anything like that. So there's no conversions. So I'm just straight up putting the numbers in there. You with me?
Yeah, and this formula is the same as like the velocity formula, isn't it? Like rate isn't that technically like velocity, like speed?
Mm-hmm.
So it's like the same like.
But velocity has direction.
Yeah, it's just a magnitude, right?
Mm-hmm. It has a no. It's velocity is magnitude and direction.
Yeah, and yeah.
Like, so, like, speed would be 20 miles per hour.
Oh yeah.
And velocity is 20 miles per hour north.
Yeah.
So I can go 100 miles per hour down your street, and then 100 miles per hour back, and I kept going 100 miles per hour this way, then 100 miles per hour. Whereas velocity, I went 100 miles per hour and then a negative 100 miles per hour. Okay. Cool. And this distance, I'm just thinking, this distance right here, that this thing is traveling, like it's at 1 mile per hour, it's going to travel some distance. It's going to travel some distance x.
Mm-hmm.
Like if you think of this as like a number line, like 500. Well, let's say they meet up at 500, right?
Mm-hmm.
So this thing, let me think. If they meet up at 500, then this thing had to travel 500 minus 260.
Mm-hmm.
Whereas this guy over here had to travel the full 500.
Uh-huh.
Right? So the ship has to travel full x all the way to 500. And the iceberg has to travel
240.
So is it 240 or 260? 260. So it's going to be right, 240 if that was the real number.
Yeah.
But it's not the real number. The real number is x. So it's traveling x minus 260. Does that make sense?
Yeah.
That's it. Yeah. So x right because this is 260, right? So x minus 260 would be that.
And were we given the time?
No. So and
We're looking for the time.
Yeah. Well, is that everything we have? I think it's everything we have, right? But you can find the time. You can find the time by, if you wanted to, doing a little algebra. So if you have d equals r times t, you can isolate t by dividing both sides by r. See, so time is equal to d over r. Well, here, that's x minus 60 over 1. That makes sense? Or x minus 260, I mean. Over 1, which is just x minus 260. Then what would the time be over here?
It would be x over 15.
Correct. X over 15.
And then...
Now, what's the thing that we know for sure is true? Are they both traveling the same distance?
Yes.
Are they both traveling for the same amount of time?
Are
they meeting? Are they
traveling
meeting
for the same amount of time?
Same amount of time. The distances
are
are
different.
different.
X minus 260 equals x over 15.
Yes. So, so if you set these equal to each other, you're gonna find what x is, and then you could. What do they want? I guess
Time.
you could plug it back in to get your time. Don't just get excited about solving for x. I've done that many times. Okay. So hit both sides by 15. Let's kill the fraction. I like that method. 15, 15, 15. So 15x minus 15 times 260. Quick, that's a math.
700,
15 times
3,020, 3,030, something. I don't know, something like that.
It's a good estimate.
3,009, no, 3,800.
Equals, and then these guys right here. Wait.
Oh, yeah, 3,000. Yeah.
I got that. All right, so then I'm going to move the x over here. And I'll get 14x. So far I feel confident because I know that I don't have a negative time or something. Okay, then 0, then plus 3,500. But I don't like this number. 15 times 260. 3,900. Oh, look. That looks like a 5. And error. 3,900. 3,900. 3,900. All right, so 14x equals 3,900 divided by 14. Divided by 14.
280.
So it's, hold on. Pause. Wait, let's see what they want here.
Time.
Oh, they want it down to like
Hours
hours and minutes. All right, cool.
So 280 seconds, right?
So I'm just going to hold it in the calculator. Because, well, here. I got x is equal to 278.5714.
That's seconds, right?
That's just, well, no, that's just x. So that actually, that's the distance that ship traveled.
Oh, yeah. Oh, and then the distance to the iceberg is that minus 260.
So wait, oh yeah, because if you think about it, it travels 278 because this guy has a slowpoke. It doesn't have to travel much. Like, he's only going 1 mile an hour, so he's gonna gonna pass it up quickly. In fact, if you wait a minute.
Oh, well, now you just need to plug in x, and then they both are the
But
same.
you know
So just plug in x into one of them, and then
Right, and this is actually time. So if you want to find, what do they want again?
time.
Oh, yeah, time.
The hours and minutes.
You could plug it into either one, and you're gonna get that. You're gonna
Probably
get
the ship one would be easier though.
Okay, well, if we turn this number to a fraction, that doesn't help. Well, okay, so I'll write it as a fraction actually. So I hit math, enter on the calculator, and I got it as 1950 over 7.
A little bit better.
And then you go, so to get
the
time, so x over 15, so, oh, I see.
T equals
honestly,
t over...
Honestly, you could just go that number divided by 15.
Yeah, we probably shouldn't do a fraction then.
Yeah.
Probably put back in
All
the
right,
278 form. Because then why you have to, do the split.
Just, hold it in the calculator. Whoa. Just hold it in the calculator, and then go over 15. So, over 15. No. So it's...
Yeah, it's 15.
So, t is equal to 278.5714 over 15. So divided by 15 is 130 over 7, which is, 130 over 7, which is 18.5714, which is 18.57142.857. All right, so, and time is, it's been the same, it's been the same unit of time this entire thing. So, all right, so that's going to be one, let me think. Oh yeah, okay, fine. So that's 18 hours.
Oh, really?
That's 18 hours. No, I guess it makes sense because look, it's still 260 miles on a boat. Okay, so 18 hours. So yeah, it's not a lot of distance, like with respect to how far apart they already are. Because like it's 260 versus what did it have to do? 278, right? But it takes a long time to do that.
It's only going 50 miles per hour to go.
And the other one's going 1 mile an hour.
Yeah, so to go 278 miles going 50 miles per hour, it's gonna take a lot of time.
So we're gonna take this to minutes, which is 0.57142857 hours. Okay, so so you're gonna go 1 chemistry style. I'm gonna say that 1 hour is 60 minutes.
Mm-hmm.
I know I did it right because I got minutes on top.
And you can wipe out the hours. So.
Wipe out the hours and then times 60. Oops, only the 0.57 business though. So wait, minus 18.
R.
No. Here, bring that down. Minus.
Well, you have to go to the right part.
Minus 18.
You didn't go to the right part.
There. Okay, so we're there. Oh, let's do that. All right, then times 60. 34.257. So that's going to be 34.2857. I think they just went down to the minute, so it's 34. So 18 hours and 30. I'll put an and, I guess. 34 minutes. Does that make sense?
Mm-hmm.
One thing real quick.
That's for if they're going in one direction, right? It's different if they're going in the same direction. I know different directions, but towards each other.
Yeah, that would be different. But this problem obviously is a calculator problem, right?
Mm-hmm.
So if you got a number like 18.5714, actually, let me think here. I think if you do, no, actually, hold on a second. Okay, never mind. That's it. That's the answer.